Video is naming with polyatomic ions. And so one of the things that we want to look at when we talk about naming polyatomics is the word polyatomic. These are located on the bottom of your periodic table, and so the prefix poly means many, and atomic would be atoms. So you're going to be looking at more than 2 capital letters in a compound. Okay, so more than 2 elements, which would be capital letters. Okay, so for instance, I'm just going to put this one up here, NaNO3. So I look at it and I see a metal, I see nitrogen, and I see oxygen. I see 3 capital letters, so I know there's a polyatomic in here. First thing I'm going to do for naming with polyatomics is you name the first substance. And notice I said substance and not element, because the first substance may not be an element. In this case, the first substance is an element, and it's sodium. Okay? Our second substance is NO3. So rule number 2 kind of has 2 parts. 2A, if it's an element, then you do the "ide" thing that we have done before, so it ends in "ide." But if it's a polyatomic, you just name it. So on the bottom of your periodic table is a list of common polyatomics. And so if you look at the periodic table, it'll show this. It says NO3 -1, and that's called a nitrate ion. So this becomes sodium nitrate. You didn't have to change anything. This is the name that was located on the bottom of that periodic table. So the good news about polyatomics is you just do what it tells you. You just name what the name has already been. You don't change anything. Okay, this 3 is part of this polyatomic. You don't change anything about it. Okay, all right, and then the third rule is check for Roman numerals. So we're going to look at sodium on the periodic table, and you'll notice sodium is just a +1, so he requires no Roman numeral. You're done, sodium nitrate. Let's try another one. Let's go Mn, and then we're going to go C2O4 is what we're going to do. So first of all, I look at it and I see a metal, and I see 1, 2, and then 3 capital letters, so I know there's a polyatomic in here. So here's my metal, and C2O4 happens to be the polyatomic. Okay, that's the second thing. So rule number 1, name the first substance. Manganese. Rule 2, if the second substance is a polyatomic, you name it. Well, it contains more than 1 element, so it's a polyatomic. C2O4 on the periodic table is called oxalate. That's its name. It's on the bottom of the periodic table where it says common ions. However, when I look at manganese on the table, it can be a 2+ or a 4+. So I have to find out who was used. So I'm going to look at the oxalate. This number down here, okay, does not mean anything for the charge. Don't look at these numbers for the charges. The common polyatomic of oxalate has a charge of 2-. So if I look at C2O4, there's only 1 C2O4. There isn't 4 of them. C2O4 is one thing. There's only 1 of them. So if he took 2, manganese had to give 2. It's manganese 2 oxalate is the name. Okay, let's go the other direction now, and let's do, if I give you name, how you would write the formula, because polyatomics tend to start giving people problems with all these subscripts and stuff. All right, so let's see. I'll give you magnesium hydroxide as a name to start. Magnesium hydroxide. All right, so I look on the periodic table. Magnesium is Mg, and he's a 2+. Hydroxide is not an element. He's a polyatomic, and he's OH -1. Okay, closest number these guys have in common is 2, so it takes 2 OHs, or we drop and switch. Mg1 OH2. So here's how we write it. Mg, we don't actually put a 1 there. OH is going to go into parentheses in 2, because this is one thing. You need 2 of those. If you don't put it in parentheses, you've now just made H2O. You made water. I don't want water. I want 2 of those hydroxide ions. So the correct formula is MgOH2. Okay, let's try another one. Let's do a lithium. Let's go phosphate. Okay, lithium's a +1. Phosphate doesn't end in ide, so it tells us it's a polyatomic, is PO4, 3 negative. The only thing you look at to write formulas is the superscripts, the cation and the anion. So he's a 1, he's a 3. Drop and switch. The 3 comes down, 1 comes down. It becomes Li3PO4. This belongs to this ion. You can't get rid of that 4, but you don't use it to combine. Just look at the charges to combine. Okay, this is your video on polyatomics. There's a couple practices. Please watch those or watch the video that shows you how to do some of the sample problems. You might run into some acids and molecular compounds, but it's okay because we're getting to those before the semester test anyways.